in the past, on the quiz, we needed to show that triangles were congruent, okay? So we're going to do some notes today. It looks a little bit different. It's just not on my iPad, but you can see that we could just write everything on here from the screen. But in the past, we needed to show triangles were congruent. How many sides are in a triangle? Three. How many angles are in a triangle? Also 3. So what needed to happen to show triangles were congruent is I needed to show that 3 angles were congruent to each other and 3 sides were congruent to each other. However, starting today, there are some shortcuts, okay? The shortcuts, instead of 3 sides and 3 angles, can be abbreviated with just letters right here. So this is on page 9 of your notes. And we're going to take a look at some shortcuts. Now, I want to be clear with you, not every single letter combination is a shortcut. Here's kind of what I mean. Look at this one that I'm pointing to on the screen. Side, angle, side, right? You can see how the SAS stands for side, angle, side, right? This is one combination of letters that can make a shortcut. 2 sides and an angle. When you look at this, the order of the letters actually do matter, okay? The order of the letters actually do matter. Thank you, thank you.
Yeah. Is Miss Summers here today?
Yeah.
She talked to you about it in an email?
Yeah.
So, one combination is getting a side, angle, side. Now, when we look at this, it has to have 2 sides and an included angle. So when I mark it right here, this could be one set of sides. Do you see how I have the green tick marks here? Right? Showing that the sides are congruent. Another way is these red markings right here. If these are given to me, I already know they're congruent. Now, here's what I want to highlight and make a special point to include. This phrase that I'm highlighting here in orange says included angle. What an included angle means is it's the angle that's between the 2 sides. It's the angle that's between the 2 sides. That is this one right here. Do you see how the 2 sides make the angle? These are the included angle right here. I want to show you an example of something that's not included. Okay, so up here in the margin, if I were to draw these same 2 triangles, and they have the same markings, right? There's a side that's congruent. Here's another side that's congruent. With the blue pen, do you see that if I circle these angles, do you see how the blue angle is not between the 2 sides, right? That's a non-included angle, okay? We are not talking about non-included angles here. But this is what a non-included angle is. So the angle must be between the 2 sides in order to be side, angle, side. Okay, so let's look at a picture here. If I'm looking at these 2 triangles, let's see if we have enough information to get a side, an angle, and a side that's actually congruent here. Is there a side on both triangles, Emma, that has at least the same amount of tick marks?
Yeah.
Which one is it?
Well, there's 2 of them.
Okay, can you just give me one combination, please?
E and C and E and F.
So E, and what did you say? Oh, B and C is what you said, right?
Yeah. And then
B and C, and then you also said E and F, right?
Yeah.
So side BC is congruent to side EF right there. And that's given to us, right? See how it shows us on the picture with the tick marks? That's given. There's also an angle. Zach, where are the angles at that are congruent to each other?
Angle B and angle E.
I love that you said it that way. Angle B is congruent to angle E, right? That's also given. And that's because it's these angles right here in the green. Zoe, what about a third side? Is there a third side? Okay, what would that be? Now, AC has no markings on it, right? What side on this triangle does have some markings? AB. So segment AB then, Zoe, is congruent to? You said D, E. Oops, you said D and I didn't write that. Yeah, DE right there. Okay? So there it is. This is also given. So what I have to do here is I have to come up with the order. Now, the order, there could be lots of different orders, but once we establish it, then we have to kind of go through it. So Kexon, what's an order for this left triangle right here? Triangle what? What would you name this? You need 3 letters and they can be in any order. A, you said what? Triangle ABC. Now, perfect, Kexon, because you chose that order, then the second triangle has to be in a certain order. So CJ, we said angle A was first. What angle is the same spot as angle A? Love it. Love it. Angle D. The next one we said was angle B. CJ, what angle is in the same position as angle B? Love it. Love it. And then obviously F, right? Now, we could have said it in a different order. Again, Kexon, you said it perfectly, right? I'm not saying that you said anything wrong, but you could have said BAC. Then, CJ, your order might have changed to EDF, right? So we have to still line those up like we always have. All right. Remember, included means the angle between it, right? Now, let's see. Do we have enough information to show that these 2 triangles are congruent by side, angle, side? Calvin, do we have one side that's congruent to each other? Okay, so there it is right there. Dane, do we have a second side that's congruent to each other?
Yeah.
What side is that on the left? And then what side is that on the right?
LK and OP.
This is one reason why I don't use this anymore, because it's the zoom or the focus feature. There we go. You said LK and OP. Perfect. And do we have a angle there? Liam, what's the angle? M and J, angle M and angle J. So, here we go. What do you think? Kelsey, is this enough to do side, angle, side? It is not. Okay? Here's why. If it was enough, remember, when we do this, look at the colors that I did. I did one of the sides in purple, and I did another side in green. Is the blue angle in the middle on the picture between the green and the purple? It doesn't look like it, right? If I were to start it, because when you do these letters, just like this right here, you have a side, angle, side, right? See how I could start and use that to make the triangle? Here, look what I spell here. angle side side. Are these the same thing? Are these the same thing? No, they're not. Also, we don't spell bad words in math class. At least geometry class. When you get to algebra 2, that's a different story. Oh, somebody's ready for algebra 2, huh? All right, here we go. This is not a shortcut. Okay? Do you see how the angle is not between the two sides? Right? This one has to have the angle between the two sides. Kelsey, let's try this again. What angle is between the two sides on the left triangle? Correct. And what angle is between the two sides on the triangle on the right? Correct. So those would have been the two that I would have had to have. Okay? Again, we're not spelling bad words in math class. All right? So the answer is no. Right? Not enough info. Okay? Let's do this one. One of the reasons why let me go back real quickly. Do you remember how I said not every letter combination is going to be a shortcut? This is a shortcut. This is not a shortcut. So we would never use angle side side as a triangle shortcut. Over the next couple class periods, I will give you all of the shortcuts, and SSS is not one of them. Okay? Here's what I want to do. This next problem, it says the triangles can be proved congruent. State which two triangles are congruent and the reason why. Before we start this problem, we need to think about everything that we've had and that we've covered in math class. Okay? One of the things that makes the proofs difficult that we're going to move to here, we did them already with algebra, but we're going to start doing them with triangles in the next couple days. One of the things that makes them the most difficult is we actually have to think about everything we've learned in geometry so far. So over the course of this period, we're going to go back and we're going to remind ourselves of previous units that we've covered. That's one of the reasons why I do the double quiz, just to kind of keep things fresh in our mind. Here we go. These triangles can be proved congruent, right? So I have two triangles. I have the one here that's on the left. Rocky, do you see those highlighters on my desk? Could you grab me a blue one in that white basket, please? And would you mind just tossing it to me? Perfect, thanks. Oh my goodness, I had a blue one right in front of me. Why didn't I see that? Okay, thank you. These triangles right here, okay? I want to prove that they are congruent. So just by looking at them, Chelsea, is there a side on both triangles that are the same as each other?
Yeah.
Which side is it?
WY and ZT.
WY and ZT. So WY is congruent to ZT. And how did you know that, Chelsea? You're right that they're congruent. How did you know that?
Because they look the same.
Okay. Yes, they do look the same, but there's something else on the picture that told you that. Not just that they look the same, but what was on the picture?
Through the line.
Yes, it was given to us, right? See how the line gave us that it was congruent? Parker, is there another side here?
Yeah. WX and XT.
So WX is congruent to XT. Again, Parker, how did you know that?
The lines give it.
It is given to us, right? Now, we know that they can be congruent. The only congruent statement I have here is side, angle, side. That's the only one I know. I, with Chelsea's help, have gotten one side and Parker's help a second side. We need to find the angle. And, Addie, what angle does it have to be if it's in the middle of those two sides? That is exactly correct. We have to use these angles right here because those are the only angles in the middle. So I know that angle W is congruent to angle T. Now the question is, how do I know that? Well, this is where it goes back to previous units of math. Look at this. Don't I have two parallel lines cut by a transversal? And isn't it these angles and these positions right there? Oops. Isn't it these angles right here in that position right there? We just did the individual quiz over this. Claire, what kind of position are those angles in? The two purple stars? Stay with us, please. They're alternate interior angles. And, Claire, one last question. When I have two parallel lines cut by a transversal, what do I know about alternate interior angles? Are they supplementary or are they congruent? They're congruent. So because of the parallel lines, alternate interior angles are congruent. So I need to think about, when I'm shown parallel lines, that those two angles are congruent because they're alternate interior angles. See how now I have a side angle side right here? That's what I'm looking for. Now notice the order. Liam, it says WXY. So again, it's WXY. What letter should I start with if it starts with a W? What letter on this blue triangle should I start with? If the orange one starts with a W? Yeah. Triangle, T, and then what has to come next? Yep, an X, and then obvs, the last letter has to be Z, and that's by side, angle, side right here. Okay, so that is one shortcut called side, angle, side. The next shortcut that I want to talk about is side, side, side. So side, angle, side was two sides and an angle. This one is just three congruent sides, right? So this one should be pretty straightforward. There's one side, then it might give us a second side, and then also a third side right here. So will you do this? Can you list the sides that are congruent to each other over here, please? Can you list the sides that are congruent to each other? My question is, does it matter which order comes first? Could I do the one with 3 tick marks first? I could. The tick marks do not have to be in order, but I need to have the same tick marks on the same line. It says then triangle CAB or CBA, let's do it that way. Kellen, back there in the corner, what order does the next triangle have to be in? If I said C, then B, then A? F, E, D. Perfect. All right. We're going to take a look at some more things where you have to recall things from previous units. So again, we did one with alternate interior angles. Here on the next page, let's take a look at this one. Does the diagram give us enough information to show that these two triangles are congruent by side, side, side? Colt, does it show us a side on the left and the right triangle that are the same as each other? Which sides does it show? Yeah, what's this side called? What's its name right here? So this one is just called XW. Remember, you only need 2 letters for that. And then, what's the other one called? Side WZ. Colt, that was given, right? See how it just gave it to us right there? So there's the first of the 3 sides right there. Rocky, do I have anything that shows me a second side? Okay. There is a second side here. Again, like I want to say, go back to what we know. Rocky, on the picture, would you agree that this side is on both triangles?
Yeah.
So here, just kind of follow my thought process here. If this side is on the left triangle and also on the right triangle, would they be the same as each other?
Yeah.
They would, correct? We call this, and going back to something we did during the algebra proof, the reflexive property. Basically, what that says is if I have a side on one triangle and it's also on this other triangle, I just know that those are congruent to each other. So there's a second side. John, is there a third side here?
The bottom.
How do I know? What do I know about the bottom?
They both share it.
They don't share it because, look, there's a part on the left and a part on the right. What does this highlighted thing say, though, John?
Y is the midpoint of X and Z.
It's given us that Y is the midpoint. So again, going back to what definitions mean. John, what does it mean to be the midpoint?
It's in the middle of the line.
So this letter is in the middle, right? So this right here is the midpoint. So if that's the midpoint, John, what 2 sides are exactly the same?
X and Y, Y and Z.
X, Y, and Y, Z. So side XY is congruent to side YZ. And what was it that told me that again? What was the word, John, that told you that those would be the same?
Midpoint.
Yes, the word midpoint. So again, what Rocky said, we knew these were the same because of the reflexive property. We knew the green ones were the same because it's the definition of a midpoint. If you recall, I said, John, what does it mean to be the midpoint? And you told me the middle, correct? So that's how I know that they're the same, because the definition of a midpoint is that the letter is in the middle of the segment. So here we go. Yay or nay? Oh, I hope it's a nay. I hope it's a nay. I hope it's a nay. So they nay. Zach, do we have enough information for side, side, side?
No.
Do we have 3 sides here?
Yes.
Do we have a reason for each one of them? We do. Given, reflexive, and definition of a midpoint. Ugh! I was hoping it would be a nay. But at last, it's a yay. All right, here's what I want you to do. On the next part, there are 8 questions. Okay, there are 8 questions. You have 3 options here. Look at the triangles, and I want you to decide, is it side, side, side? Is it side, angle, side? Or is it neither? To help you out, 2 of the 8 are side, side, side. 4 of them are side, angle, side. And 2 of them are neither. Could you check in with your table mates there? check it out, right? 8 questions. They're up here if you can't see it. I will admit, I guess, that you can't probably see them very well just with all the specific things that have to be there. But 2 of them should be side, side, side. 4 of them side, angle, side. And 2 of them neither. You don't have to do it in order. Think about it. Are you practicing it now, or are you going to practice it on the group quiz for the first time? Oh, okay. That's great. Maybe you see one of them better than the others. What I mean by that is maybe it's easier for you to say side, 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 right? Look for it side, side, side first. Look for those 2. Yeah. Let's talk about it, okay? I agree, so that's why it would be neither. I have the 8 answers up here. Anybody, any of them I can... Any of them I can explain? Sure. The question was number 6 right here. Could we explain what and why? The answer is this. Now again, we have one side that's given to us. Remember, it's not the arrow, it's the tick mark. I didn't do a good job of making sure that I circled that. But the arrows do not show congruence. So what I need then is, Parker, could you see that angle D and angle E are congruent because there's parallel lines cut by a transversal, and that's how they look right there? So those are alternate interior angles. That's how I know that happens. Now, because I proved these triangles congruent by these shortcuts, that means all 3 sides and all 3 angles are also congruent. Anybody else? Can I work any of the others or to show you? Go ahead. Number 3, you said? Number 3, what might be helpful sometimes is if you take the 2 triangles and maybe even draw them separately. And I know that's not even, they're kind of overlapping still a little bit. Would you agree, Claire, that there is one side right here on that? Would you agree that these sides were shared on there? So there's another side right there. And then this marking right here showed that the angle was. See how the blue dot's between the tick mark and the highlight? So that's why it's side angle side right there. Hey, what's up, Evie? Okay, number 7 is neither. Again, let's look at it. Look where the angle is. Do you see how I have that one side? Do you see how I have my second side? But look at this. See how my angle is not between the green and the blue? The green and the blue would have to make these angles right here. Evie, do you see how this the wrong angles that they've marked?
Yeah.
Okay, so we need to pay attention. Do not just count, oh, two sides and an angle. It's got to be side, angle, side. Look at where they are. Any of the others I can clarify. 4. 4 says neither. It's really the same thing as number 7. Do you see how it gives you a side and another side? But Kellen, to your point, since you asked the question, what angle has to be congruent in order for it to be side, angle, side? What letters between the blue and the purple circles right here? Doesn't it have to be the S right here? See how the S is not marked?
Yeah.
Nor is the T on the triangle on the right-hand side, so that's why it's neither. You know what they're doing again, right? They're always trying to do this. They're spelling this word right here, right? And that's how we know it's neither. I do want to say one quick thing about number 8. Number 8 is side, angle, side. Again, it has two sides that are shown congruent to each other. My question is, how do I know these angles are congruent? Aubrey, these green dots right here on number 8, what kind of angles are those when they're right across from each other? They are vertical angles. And if you recall from the very beginning of the year, vertical angles are congruent to each other, right? So that's what I mean. We need to kind of circle back and be mindful that there's a lot of things that could come back here for this topic. All right. Last thing I want to show here is just on page 11. Page 11 is the third shortcut we're going to talk about today. This shortcut only works in right triangles. So a triangle that has a right angle. If you have right triangles, right, again, this is a right triangle because of the right angle right here, then the hypotenuse, remember the hypotenuse is always across from the right angle. The hypotenuse and one other leg. It doesn't matter which one. It could be the one above the right angle. It could be the one below it. It could be the one next to it. But just not the longest side. If those three things happen, right triangles. Second thing, hypotenuse. Third thing, a leg. Then I know that the triangles are congruent here. Okay? So here we go. Do I have right triangles here? I think I do, right? Isn't there right angles? My question is, this right here is a leg. So angle, or excuse me, side AB is congruent to DE. And right here, side BC is congruent to EF. Then the triangles are congruent. Jacob, if I said order triangle BCA, what order would the triangle on the right-hand side have to be in? EFD, triangle EFD. So here we go. This is a yay or a nay. Oh gosh, I hope it's a nay. I hope it's a nay. I hope it's a nay. Is it possible to show that the two triangles are congruent by hypotenuse leg? So here we go. Kellen, here in the middle. Are these two triangles congruent by hypotenuse leg? I agree, right? He said no. How do I know this? I wish he would have said nay, but I agree, it's a no. Are these right triangles right here? They're not. So automatically that makes it a no, right? That makes it a no. Let's do the same thing here, but except for it says, if so, which triangles are congruent? See how there's no letters on this one, so I'm not going to worry about that. Is it possible to show that these two triangles are congruent by hypotenuse leg? So the question is, do I have right triangles?
Yeah.
I do. Do I have the hypotenuse to be the same? Millie, what do you think? Is there a longest side of the triangle that's the same? Okay, where would those be at? I know it's hard to show just because there's no letters, but where would those be at? Would that be on the sides or in the middle? I agree. So the hypotenuse right here is just what's in the middle. That goes back to that problem that I was talking with Rocky about, right? There is a side that's on both triangles. And the third thing, is there a leg? That's the last part that we're asking. Elijah, is there a leg on both of these triangles that are congruent?
Yeah.
Which ones? Top and bottom or left and right? Lefties and righties, right? So it is congruent. I have a hypotenuse leg on a right triangle right there. So what I want you to do is I want you to get some practice. Most of today's assignment is multiple choice. Could you please take a look at 4D? It's side, 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 side angle, side, and hypotenuse leg.